All right, today we're going to be learning how to solve equations that involve logarithms. Let's start with this first example, and notice our directions for this example say to solve the logarithmic equation where logs have like bases. And if you look at our equation, you can see that on both sides we have log base 10. Log base 10 of negative x plus 10 equals log base 10 of negative 4x plus 3. Hopefully it makes sense to you that if these two logs are equal, then negative x plus 10 must be equal to negative 4x plus 3. So when you've got two logs that are equal to each other that have the same base, it's a pretty simple problem to solve. I'm going to just do some basic algebra here to solve for x by adding 4x to both sides and subtracting 10 from both sides. And we're going to get 3x equals negative 7 and divide by 3 to get x by itself, and x is equal to negative 7/3. So pause the video for a moment and try the next one on your own. If you were successful on this next problem, you should have ended up with x is equal to 13. We just start off by recognizing that both sides have a log base 5, and so we can set 5x minus 9 equal to 4x plus 4, and then solve for x. Let's look at the next example. In this one, it's not going to be quite as simple because I don't have a log on both sides. I just have this one logarithmic expression. So if I'm going to solve this, I need to get this logarithmic expression all by itself. Just like we were doing with the exponentials, you need to get that expression by itself. So I'm going to start out by adding 7 to both sides. And so I have log base 9 of 8x is equal to negative 2. So now I have the log by itself. And so this is the point where I need to undo the logarithm. Now if you remember, logarithms and exponentials are inverse operations of each other. In the previous examples, in the previous video, we were undoing exponentials by using a logarithm. Now we're going to undo a logarithm by turning it into an exponential. I need to notice that my base here is a 9, and so what I'm going to do is make this expression an exponent on 9, because remember, logs are exponents. So I'm going to write it as an exponent on 9. And then of course if I do that on the left side, I have to do it on the other side as well. Now that I have 9 to the log base 9 of 8x, these can cancel out. The 9 and the log base 9 cancel out, and I'm just left with 8x on that side. Now on the other side, I have 9 to the negative 2 power. Little exponent review for us. If I have a negative exponent, that's going to put that 9 in the denominator, and that's going to be equal to 1 over 9 squared. Or if you wanted to write it as 1 over 81, that would be fine as well. Last step, we just need to divide by 8 to get the x by itself. And x is equal to 1 over 648, which is approximately equal to 0.0015. Pause the video, try the next one on your own. If you were successful on this one, you should have ended up with negative 35 over 12, or maybe you have your answer written as negative 2 and 11/12. Either one of those answers is okay. I forgot to get a decimal approximation on this one. If you happen to have a calculator, your decimal answer would be negative 2.917. So all we did on that question was starting out by dividing both sides by negative 6. Again, you have to get the logarithmic expression by itself. So we need to cancel that negative 6. And then this time our base was 12, and so we made both sides of the equation exponents on 12. Our log canceled out, and then we just go through the algebra to solve for x. Let's look at the next example. In this example, I've got to use my log properties before I can start solving the equation, because I've got these two log expressions over here, and I need to combine them together into one expression. It's kind of like combining like terms, which you learned how to do in Algebra 1. Now I've got two logs that are being added together, and hopefully we remember that that means that we're going to apply the product property, and so I can rewrite this as x, the log base 7 of x times x plus 21. And that's going to be equal to log base 7 of 46. So again, we were adding these two logs together, and remember, logs are exponents. And whenever you're adding exponents, that means that you're multiplying. And so we can rewrite this as a product. Now I've got a situation where I have log base 7 on both sides of the equation, log base 7 and log base 7. So I've got like bases on my logs, so I can just say that x times x plus 21 is equal to 46. But we still need to solve for x. So I'm going to distribute the x over here on the left, and we get x squared plus 21x equals 46. Now, a little Algebra 2 review for us here. We haven't done much factoring this year, but we're about to, and so this is as good a time as any to review the skill. Whenever you have a squared in your equation and you need to solve for x, we've got to get it equal to 0. We need to get everything on the same side. So I'm going to rewrite this as x squared plus 21x minus 46 is equal to 0. Now, to factor this, I'm going to start out by multiplying the first and last terms, and I'm going to write that product over here on the side, negative 46x squared. And then I'm going to list the factors of negative 46x squared. And the only ones that I can think of are 23x and 2x. And I guess, of course, there's always 1x and 46. 23 and 2, if I subtract them, will give me that middle term of 21. And since this term is negative, I do need to subtract them. So I want a positive 23x and a negative 2x. So now I'm going to go back and rewrite. X squared plus 23x minus 2x minus 46 is equal to 0. So all I've done in this step is taken the 21x and rewritten it as 23x minus 2x. And now we're going to factor by grouping. I'm going to group these first two together, and out of those two terms I can factor in x, and I'm left with x plus 23. Out of these two terms I'm going to factor in negative 2, and again I would be left with x plus 23. So now I've got two terms, they both have an x plus 23, so I'm going to factor that out, x plus 23, and x minus 2. Those are my factors. And then, of course, if I'm multiplying two things together and the answer is 0, then either one of those factors could be equal to 0. And so I'm going to say x plus 23 equals 0, x minus 2 equals 0, and therefore x is equal to negative 23 and x equals positive 2. And those would be my final answers. Now, if you don't remember how to factor, don't worry about that so much right now. The next example that you're going to try does not involve factoring. Right now, let's focus on solving log equations. We'll review factoring soon. So pause the video, try the next one on your own. If you were successful, you should have ended up on this one with negative 16/9, or approximately negative 1.77. So we just started out again by applying that product property, multiplying the negative 2x times 9 to give us negative 18x. Now this one we didn't have logs with like bases on both sides. I had to make both sides an exponent on 2 so that I could cancel out the log base 2. 2 to the 5th is 32, and I had negative 18x on the left side. And I'm going to divide both sides by negative 18, and that's how we end up with our answer. Let's move on to the next example. Here I've got log base 7 of x plus 1 minus log base 7 of x equals 2. Now remember, logs are exponents, and if I'm subtracting exponents, I subtract exponents when I'm dividing. So if I'm going to rewrite this and combine them together, log base 7, I want to divide x plus 1 divided by x. And that's going to be equal to 2. So now I've combined my logs together. I have a single logarithmic expression. And I need to undo that log. And remember, to undo logs, we need to turn it into an exponential. My base here is 7. So I'm going to make both sides exponents on 7. 7 to the log base 7, x plus 1 over x, is equal to 7 squared. The 7 and the log base 7 cancel out. They undo each other. And so I'm left with x plus 1 over x is equal to 49. 7 squared is 49. And now I need to solve for x. If you would like, you could put this 49 over 1 and think about this like a proportion. We're going to cross multiply. So if I do that, I get x plus 1 is equal to 49x. And then I'm going to subtract x from both sides. 1 equals 48x, and finally divide by 48. And x is equal to 1 over 48. If that's cut off on your screen, sorry about that. X equals 1 over 48. All right, again, pause the video, try the next one. If you were successful on the next one, you should have ended up with 6,144. These numbers got a little large here, but the problem starts off in the same way. Applying that quotient property, the log quotient property, I'm going to rewrite as log base 2 of 2x over 3 equal to 12. To undo the log, we're going to turn it into an exponent on a base of 2, which cancels out. And I've got 2 to the 12th on the right side. So I'm left with 2x over 3 is equal to 4,096, which I got from my calculator. And then we just solve for x. Multiply both sides by 3 and divide by 2, and you end up with 6,144. Let's look at two more examples. This one, very similar to the examples that we just finished, except that it involves the natural log. The log properties are the same. If I'm subtracting, I'm going to use that quotient property. Rewrite this as natural log of 4 minus 2x divided by 9, and that's equal to 3. Now this time, to undo the log, I'm still going to turn it into an exponential. I still want to use the same base, but I need to remember that the base of the natural log is e. And normally we don't write it, but I'm going to put it there just to be clear and remind us that that's our base. And so to undo a natural log, I need to make it an exponent on e. So I'm going to say e to the natural log of 4 minus 2x over 9 is equal to e to the third, making both sides exponents on e. The e and the natural log undo each other, and I have 4 minus 2x over 9 equals e to the third. And now we just need to solve for x. Multiply both sides by 9. So 4 minus 2x is equal to 9 times e to the third. And I'm going to subtract 4 from both sides. 9e cubed minus 4. And finally, last step, divide by negative 2. So I'm ending up with x is equal to 9e cubed minus 4 divided by negative 2. And if you have a calculator handy, you can type that in. You would get negative 88.384. All right, one more time. Pause the video and try the last one on your own. Final example. We should have ended up with 6e to the 5th plus 5 over 2, approximately equal to 447.739. Again, we started off by applying the quotient property, rewriting as a quotient. We're using natural log, and so our base is e, and so we made both sides exponents on e. The e and the natural log cancel out, and we're left with 2x minus 5 divided by 6 equals e to the 5th. And from that point, we're just solving for x. Multiply both sides by 6, add 5 to both sides, and finally divide by 2. And that's the end of our logarithmic equation examples.